Hello. I'm going to be resolving problems 13 and 14 from test number 2. For problem 13, on the original test, I did not use logarithmic differentiation. Instead, I just used regular implicit differentiation, just like so this time we'll be using logarithmic differentiation, which starts off by applying ln to both sides of the equation. Once we apply this, we need to use logarithmic rules in order to work it out. Once we do that, we get to this x ln x minus, since powers are applied to the front, once you make it an ln x, so you get 1/2 ln. Sorry, that should be plus, not minus, plus 1/2 ln x plus 1. That would be the product rule ln for that derivative, and for the whenever you divide by something, you use a minus. Now that we're at this point, we can start to use implicit differentiation, which when we apply it to ln y, we have to use the chain rule. Once we apply the chain rule, it works out to 1/y times the derivative of y. And then moving on to x ln x. For this, we have to use a combination of both the chain rule and the product rule. So in order to do that, we're going to ln x. Once we apply the chain rule to ln x, we get the derivative as 1/x. And the derivative of x is 1. Now we apply the product rule, we get x times 1/x, which is 1 plus ln, or we can do it the other way around, ln x plus 1. Now for 1/2 ln x, we don't need to worry about the product rule, so we just need to use a chain rule once again. For the derivative of ln x plus 1 is 1/x plus 1. And multiplying that by 1/2, we get 1/2 times x plus 1. Then we do ln 2 x plus 3. Use the chain rule once again. The derivative of 2x plus 3 is 2. So we work out the root of ln 2x plus 3 is 2/2x plus 3. Then we multiply that by 7, and our final answer is 14/2x plus 3. Like our final answer, in order to get the derivative of y on its own, we multiply this side of the equation by y to get rid of 1/y, and we can find the value of y by looking at the original equation. So our final is the original equation that's our final answer. Now moving on to problem 14. In the original test, I had trouble with this one because I couldn't figure out the value of z or the derivative of z, so I couldn't figure out how to solve it. But now I've refreshed myself, I can find the answer to it. So first thing we do is find all the values that is given to us and use them to draw a graph. So the graph can be drawn as a triangle since it's a ladder leaning up against the wall. The value of z representing the length of the ladder, the value of y representing the length of the wall, the value of x representing the length from the wall to the bottom of the ladder. And the equation gives us the value of x. That says when the bottom of the ladder is 5 meters away, so x equals 5 meters. And it also gives us the derivative of x. But it says it slides away from the wall at a rate of 0.6 meters per second. So the derivative is 0.6 meters per second. And even though it does not give us the value of y, it does give us the derivative of y when it says it slides down at a rate of 0.5 meters per second, or 0.25 meters per second. So its derivative is 0.25 meters per second. And now we have those values. We can apply the Pythagorean theorem, which is x squared plus y squared equals z squared. We can use differentiation on this. Once we do that, we get 2x times the derivative of x over t with respect to z plus 2y dy. D equals 2z derivative of z. Now before, when I was doing this from the original test, I couldn't figure out the value of z or the derivative of z. However, I now realize that since it is a ladder and its length cannot change, that means it has no derivative. It has a derivative of 0. That means we can put left side the value to the right 0. And we simply apply what we already know about x, the derivatives we were given. So that works out to and since the ladder is going down, and so that means that the derivative is decreasing, we put it in the equation as minus or negative 1.5. Okay. Once we work it out a little bit, we get a value of 6 plus negative 0.5y. Equal to 0. Now I can subtract 6. Divide by negative 0.5. So y becomes equal to 12. Now we have this, now we have x and y, we can apply it into the original equation in order to find the value of z. So 5 squared plus 12 squared equals z squared. That's 25 plus 144 equals z squared. When I add those together, it's 169. So we find the square root of 69, we find the value of z. And the square root of 169 is 13. So that is our final answer for the length of the ladder. And this concludes my presentation.